Alright, we are going to do a satellite problem. Your teacher should have this handout for you. If not, ask him or her for one. Basically, you have a satellite moving in a circular orbit around planet Earth. Okay, so the question is entirely in variables, and the first part asks you to find the speed of the satellite. So say to yourself, okay, it's moving in a circle. I know there's centripetal force then. And when you write down the equation for centripetal force, this is always the mass of the object moving in a circle. So clearly I'm calling my satellite, draw a picture of my satellite. It's a box with popsicle sticks. Okay, there's my satellite. It has mass little m. Anyhow, this is the mass of the satellite, or the mass of the object moving in a circle. That's its speed, and that's the radius of its path. So if we look at this circular path, that radius is from the center of the Earth to its orbital path. Alright, now, then ask yourself, what is causing this satellite to move in a circle? Well, that would be the force of gravity. Now, we know the force of gravity is Fg equals mg, but in this case, we have to use the universal law of gravitation because we don't know what little g is way out here. So the universal law of gravity, according to Newton, is big G, which is a constant, the mass of each object, so the mass of Earth, the mass of the satellite, over the distance between the two objects squared. So this is the distance between both objects. Now note, in this case, that is going to be from the center of Earth to the center of satellite. So that also is that same distance that we were looking at a moment earlier as far as the radius of the circular path. These two values are the same. Alright, now, when you look back at the circular motion, you ask yourself, what causes this object to move in a circle? It's the force of gravity. So let us go in and plug in the force of gravity for the centripetal force. And we're going to have big G, the mass of the Earth, the mass of the satellite, over r squared equals mv squared over r. If you look at this, the masses nicely go away, and I'm getting a little excited because I have the speed. I'm asked to solve for the speed, so I'm going to get rid of this value of r, and I'm left with v squared equals big G times the mass of the Earth over r. So in other words, v, the speed of the satellite, is big G, the mass of the Earth, over r, and I'm going to take the square root. Okay, this was v squared, this is now v. Now, r was not given, so be forewarned that whenever you have a problem that is entirely in variables, you have to use the variables given to you. So this is r, this is the radius of the circle path. It's also the distance between the center of Earth and the center of the satellite. So looking at what you are given, this value is the same as the radius of the Earth plus the additional height above the Earth. So your final answer is, the speed of the satellite is the square root of big G times the mass of the Earth over the radius of the Earth plus h.